Subscribe now and click on the bell icon to never miss learning from Vedantu.
All right. So now people, So now what we are coming to is an AB5 kind of a species. Okay. So what's going to happen over here? हाँ, I know धीरज happens. कोई बात नहीं, तुम्हारे को तभी लिंक दे दिया मैंने उसमें. Now it is getting into more interesting realms. Okay. प्रतीक बाद में बात कर रहे हैं माउस एंड रैट का. Rat is something that you have in your homes with those pointed ears. Mouse is Tom and Jerry वाला जो था, गोल गोल कान वाला, वो माउस होता है. Okay, AB5. Okay, we'll think about a structure that is PCl5. Okay, so what happens in PCl5 is, I'll try to draw some 3D type of a thing over here. Okay, and then this. Okay, this particular structure. Can anyone tell me what this structure is? So you know what's happening over here. Phosphorus is here. There is a chlorine. There's a chlorine. There's a chlorine. 3 chlorines in the plane. Okay, Gurjeet, I'll tell you why I've drawn them differently. Okay, there's a phosphorus in the middle. There are 3 chlorines in the plane of phosphorus. Okay, 3 chlorines in the plane of phosphorus. Then there's 1 chlorine on top of this. I just told you the geometry of a samosa. This is exactly what a samosa will look like. Not exactly, but if you assume that they've filled it up nicely with aloo. Things, yeah. So we'll call this trigonal thingy in the center, but there are 2 protrusions, bipyramidal. Okay, if you want to see this in this particular case, let me remove this. Can you see? So there is this trigonal thingy in the center. Okay, there's this trigonal thingy in the center, and on top and bottom there are 2 protrusions. Okay, these 2 protrusions are called pyramidal thingies. Okay, so this molecule geometry and electron geometry are trigonal bipyramidal. Okay, if you look at this angle, you can see that trigonal, and on top and bottom there are these 2 protrusions. So trigonal bipyramidal. Okay, imagine कर सकते हो तुम इसको करना है तो. So just look at this. In the trigonal case, of course, the angles are going to be 120 degrees. Yeah, trigonal case जो होगा वो 120 degrees पे होगा, of course. But the protrusions on top and bottom, they are going to be at 90 degrees from the trigonal case. अरे यार सीधा हो जा. Can you see this? ठीक है, trigonal case जो खुद है, that is 120 degrees, and on top and bottom the protrusions are 90 degrees from these trigonal cases. Yeah, so this angle which is in your plane is 120 degrees, and this angle between the trigonal and the pyramids is 90 degrees. Sayyid, hybridization is also a theory that gives you shapes. Okay, all of you must be wondering, sir, hybridization में भी ऐसा ही कुछ किया था? Yes, because hybridization and valence shell electron pair repulsion theory are the same thing, because they explain shapes of molecules. Okay, so hybridization is just a fancier way of VSEPR. We'll do that eventually. Okay, so these are known as axial bonds. Okay, these are known as axial bonds, and the red ones that I've made, these 3 red ones that I've made, okay, these are known as equatorial bonds. Okay, equatorial because equator is the center, Yeah. So in the center you have equatorial bonds. On top and bottom you have axial bonds. Okay. As you can see over here, this visualization is better now. यार धीरज पता नहीं कहीं पे यूज करते होंगे उस टर्म को, तो नॉट श्योर एग्जैक्टली. देखो जरा इसको. ओके. Axial bonds, equatorial bonds. Equatorial are 120 degrees from each other, axial are 90 degrees from each other. So there's a trigonal and there's a pyramidal. Yes, exactly, Manav. Axial ones are the ones on top and bottom, and the equatorial ones are in the plane. Yes, exactly, Gunjit. In offline, you know, we used to take models, वो जो models आते हैं molecule बनाने के, उससे भी हो जाता है. ठीक है? So geometry and shape are the same. बात खत्म. Think about it. Syed, think about it. Syed is pointing out a very important thing. Just look at the statement that's given over here. Axial bond is longer than the equatorial bond because axial bond experiences greater repulsions. Think about it. ये axial bond है, right? इसके 90 degrees पे there are 3 equatorial bonds. Yeah, at 90 degrees to the axial bond there are 3 equatorial bonds. Gets repelled. Think about an equatorial bond. It has just 2 things at 90 degrees and 2 are at 1 a little longer. Aditya, we'll get to it. We'll get to it. Only when you have lone pairs in the picture, then the geometry and shape is different. Okay. When there are no lone pairs in the central atom, geometry and shape are same. Now let us think of a deviation. Okay. Now let us think of a deviation AB4E. Okay. So can anyone tell me an example of this case? Does anyone remember any example like this where there are 4 bonds and 1 lone pair? किसी को याद है तो बता दो, otherwise I have it somewhere in the slide itself. प्रतीक क्या बोल रहा है मेरे दोस्त? CH4 अभी तो करके खत्म किया अपन ने. How can CH4 have a lone pair on it? PCl5, Khushagam, we've just done it. PCl5 doesn't have a lone pair on it. It is P and Cl5, that's all. Yeah. दुनिया कहाँ पे दिमाग खराब हो गया तुम्हारा? SF4 is a correct example. Yes, yes, Aditya. सही बोल रहे हो तुम. Yeah. So there is SF4. Okay. There are 4 bonds and 1 lone pair. Bonds, lone pair. People, दिमाग अपना इधर उधर मत लेके जाओ बिना मतलब के. Yo, Aditya is like proper prepared with his homework. Good job. चलो सही है. So AB4 में SF4. Okay, people. So there is S and there is 1 lone pair and 4 fluorines. People, can you tell me where would the lone pair want to go? Will the lone pair want to go in an axial position or will it want to go in an equatorial position? People think. Axial has more repulsion than equatorial. This is what we've studied just now. Lone pair is like a dominating fat thingy. It doesn't want repulsions. Axial bond में अपन ने पढ़ा अभी, we just read it, that axial bonds have more repulsions. Yeah. So the lone pair will go on an equatorial position. Okay. There is 1 fluorine that is here, 1 fluorine that is here. Okay. And then 1 fluorine on the top and 1 fluorine on the bottom. Okay. 1 fluorine on top, 1 fluorine on bottom. Okay. So people, just to give you a better structure over here, since there's a lone pair, okay, all of this will get a little squished now. Okay. So इसको यहाँ डाल देंगे. The whole structure will get squished just a little. Okay. So I'm sure that you can imagine that this angle is now less than 90 degrees. Okay, this angle is now less than 120 degrees. Nahi Manav, it doesn't, yeah. That is what I'm saying, right? Repulsion between bond pair, lone pair is high. Now, if you put it in an axial position, the lone pair is going to be troubled by 3 bond pairs. But if you put it in an axial position, it is going to be troubled only by 2 bond pairs that are in the axial position. This is something that we just discussed in the last slide. Okay, axial by default faces a lot of repulsion. So why do you want to create that repulsion even more by putting a lone pair instead of a bond pair over there? Yeah. All right. Okay, so this is going to be the case, people. Now, the geometry. People, what is the geometry over here? Geometry comes from the standard case. We've just done that. Can you tell me the geometry? Geometry ke liye think of PCL5. Think of AB5. Yeah. So it is a trigonal bipyramidal. Yeah. Now, people, can you think of the shape of this? Can you think of a shape for this? So you know what the shape actually is? I don't know who thought of it, but the shape is called a seesaw shape. Okay, let's just see the imagination. Not the imagination, I mean, let's see the animation. Okay, so इसको हटा के एक lone pair घुसा दो यहाँ पे. Somebody thought that this looks like a seesaw. Can you also think that it looks like a seesaw? Let's say Gunjit is sitting here and let's say Sayyid is sitting here. So you can apparently, yeah. So imagine that these two legs, okay, this and this are planted in the ground, and here one person can sit, here some other person can sit. Yeah. So if you put a lone pair, if I show the lone pair is like this thingy in the middle. Okay. So yeah. Let's make Dheeraj sit here and let's make Aditya sit here. Apparently this becomes a seesaw. Okay. So the example that we had taken was for SF4. As you can see, this is the case. Okay. Okay. So this axial versus equatorial bond angle is now 87.8 degrees. That is less than 90. And look at this equatorial versus equatorial angle. It is now 101.6 degrees instead of 120. Okay. So you don't need to remember these values, just showing you for the sake of showing them. Right. So this is known as a seesaw shape. Okay. People, one more weird structure now. Let's think about AB3E2. Let's think about AB3E2. Can anyone tell me a molecule that satisfies this one? Even I don't remember one. So does anyone remember a molecule that has a central atom, 3 bonds and 2 lone pairs? Shruti? First of all, that is ionic. Second of all, Shruti, this is not the case. It's this. Okay, there's 3 aluminiums and 2 oxygens. So, okay. Anyone who remembers this? ClF3. Girja Patil, I think you are correct. Let's see what shape it is. BRF3, ClF3. Yes, Girja Patil, good job. No problem, Shruti. Happens at times, okay? So, yes, let's take ClF3 or BRF3. All of these work. So, this will have 2 lone pairs on it. Okay? Right. So, now people, I am sure you can imagine that these 2 lone pairs will go in the equatorial positions once again because of less repulsion. So there's bromine. Let's say that there's a lone pair here. Let's say that there's a lone pair here. Okay, and there is going to be a fluorine in the plane itself. Fluorine in the plane itself, and one fluorine over here. I am not drawing it straight because the lone pairs are going to cause a deviation in the bond. So two fluorines in the axial positions, but the bond is going to be slightly squished. Okay, so this particular angle is going to be less than 90 degrees. Yeah. So again, people, the geometry is going to be the same. Trigonal, bipyramidal. Yeah. Can you tell me what is the shape in this case? I don't know if you have read it or if you can imagine what the shape is. But some scientist thinks that it is known as the T-shape. Okay, so imagine it like a ghatiya sa T, something like this. It should be called an arrow shape, but pata nahi kisko T yaad aa gaya ise dekh ke. So it is called a T shape. Okay, let's see. Xenon F4 will also satisfy. Nahi, Xenon F4 to galat ho gaya. Is there a... Yeah, here you go. So can you see two lone pairs and one bond pair in the equatorial plane and two bond pairs in the axial plane? Okay, so the angle is less than 90 degrees now, and this apparently looks like a T. ठीक है भाई, लगता है, काफी हद तक लगता है. Yeah. So the lone pairs are going to be here. This apparently looks like a T. T. This is known as a T-shaped molecule. Yeah. Chalo, people, this was AB5. So seesaw shape dekh liya, T shape dekh liya. Now let us look at AB2E3. Okay, this is going to be one more interesting case. AB2E3. People, this is going to be simple. I am pretty sure this is going to be simple. Okay, so the example for this is xenon F2. Okay, AB2F3. All right, and this is going to be very simple. There's a xenon over here. There are three lone pairs. Okay, and on top and bottom there are fluorines. Okay, so people, the geometry is again going to be trigonal, bipyramidal. Yeah, and what is the shape? Forget about the lone pairs. Just look at xenon, fluorine, fluorine. Yes, the shape is linear in this case. I am sure all of you can imagine. You know? This is linear. Dheeraj, the T is not like this. The T is slightly this. Okay. Okay. So the ideal T would be this, but the T in BRF3 or ClF3 is something like this. Okay. Yeah. So this is linear, people. AB2F3. An example is this. This is linear. नहीं आदित्य, लोन पेयर axial में जाता ही नहीं है. It always goes to equatorial positions. ठीक है? So yeah, this was an example. XCF2. Cool. Now people, let's get to an AB6 kind of a structure. Okay, so an example would be SF6. This is once again a standard case. Yeah, AB6 is a standard case. So यहाँ पे जाके देखते हैं. AB6, this is a standard case. Okay, you can imagine it something to be like this. This species is called octahedral. Okay, all of the angles are 90 degrees. All of the angles are 90 degrees. Yes. Okay, it derives out of an octahedron. This is an octahedron. Okay, this thingy is an octahedron. Okay, so in the middle of the octahedron, in the 3D center of this octahedron, there's the central atom, and on the vertices you have the side atoms. ठीक है? So sulfur, fluorine, 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 fluorine in one plane, and other fluorines in these two planes. Okay. यार octahedral है ना, तो यहाँ 8 faces है actually. 1, 2, 3, 4, 5, 6, 7, 8. Can you see the 8 faces? So hedra means face. Octahedron means 8 faces. Tetrahedron means 4 faces. Okay. So this is a tetrahedron. Yo, exactly. You said phases. I said faces. Not phase, face. Facade. Yeah. Okay, people. So this is an octahedral thingy. Dheeraj, the air conditioners in this office somehow cause an allergic reaction to me. I don't know क्यों होता है वो. ठीक है प्रतीक, don't worry. It's face. Okay, ये जो शक्ल है ना इसकी. Yeah. People, do you know the meaning of the word facade? English lessons once again. Do you know the meaning of the word facade? Does anyone know? जिसको नहीं पता वो गूगल कर ही लेगा. खुशगम कहाँ गया तू दोस्त? Need your Google skills. Yeah, it is French. It is a Caesarea actually over here. No, not this one. I think it's this one. अरे भाई फसाद नहीं. I am not talking about facade. This is facade. Okay, so it is basically the front face. Okay, the principal front of a building, the face. Okay, facade. I don't know if you can hear that, but ठीक है. Okay, so ठीक है भाई, जो भी है. Technically in French, there's this. ये वाला सी देखा होगा ना तुमने? So it is sir, not k. Anyway, ठीक है, enough randomness. Okay, so now let us think about the deviations of. खत्म हो गया almost, yes. So let us think about AB 5E and AB 4E2. Okay, यही सोचने की जरूरत है. There's no need to think about the other deviations of AB6. Okay. So people, let's think about this now. AB5E. Now, since in the octahedral case, all of the bonds are the same. Okay, so you replace any one of them with a lone pair. Okay, so can anyone tell me an example of this? Anyone tell me an example of this? Janardhanan, AB6 is standard, all bond pairs. AB5E is a deviation. 6 electron pairs, 5 bonding and 1 lone. Okay, so yeah. So AB5E ka example I'll also see from here. It is BRF5. Okay, so this has 1 lone pair, 5 bond pairs. So what will happen over here is you have a bromine, just put 1 lone pair on top of it, and the rest are going to be bond pairs. Yeah, fluorine, 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 and 1 on the bottom, fluorine. So people, the geometry, what is the geometry over here? Comes from the standard case quickly. Let's do this and wrap up the class. Fatafat se. What is the geometry? Yes, it is going to be octahedral because the standard case is AB6. So the shape, can anyone think of the shape? It looks like a square with 1 protrusion. Square planar अगला वाला है सुमानी. Aditya. Square planar is the next one. People, this one, there is a square but there is a protrusion. So what will you call it? You will call it a square pyramidal. Okay, always think like this. There's a square and there's a protrusion on the bottom. So square pyramidal. Okay. If you want to see the visualization, I'm sure you can do it yourself now. Yeah. So there's a square and there's a pyramidal thingy on the bottom. Let's not show the bond angles over here. The bond angles can be seen in a real case, BRF5. Yeah. So a little less than 90 degrees, 84 degrees. Right. So this is a square pyramidal. So you can see there's a square on the base and there is like this protrusion. So square pyramidal. Okay. Once it's a 3D shape. बाद में देख लेना यार उसको. Let's complete what we are doing right. Chemistry nomenclature यार. Okay. Samyukta, in the previous case, the angles are going to be 90 degrees because lone pair तो पहले ही ऊपर नीचे हो गए ना. So the square is going to be actually a square. So look at this. This is a pentagonal pyramidal. I don't know why they don't call it pentagonal bipyramidal, but there are two protrusions out of it. Okay. So there's 1, 2, 3, 4, 5, 6 and 7. Okay. So is there a way to create that over here? I'm not sure. कितने भर सकते ना? यहाँ octahedral तक ही दिखाया है इन्होंने. Is there an IF7 over here? No, there's not. Anyway, look at XCF4. Okay, so the angles are 90 degree over here. Yeah. Let me see. Pentagonal bipyramidal. Yeah, this is pentagonal bipyramidal. पता नहीं वहाँ pyramidal क्यों लिखा है. Okay. So this is what a pentagonal bipyramidal will look like. IF7. Okay. So this is a pentagonal bipyramidal. ठीक है? This is going to be the case. So the equatorial bonds are going to be 72 degrees. The axial bonds are of course going to be 90 degrees once again. ठीक है? Pentagonal bipyramidal. So people, that is VSEPR theory. Now, all that you need to do from your end is practice it a little and then you'll be quite good at it. I am definitely sure. Okay. So what we've done today is VSEPR theory. I'll tell you, Gunji. रुक जाओ. Tutorials में बताऊंगा मैं. VSEPR theory अपन ने किया आज. Okay. The thing that is there for VSEPR is lone pair greater than lone pair bond pair. And greater than bond pair. Okay. So the standard structures that we did, okay, the standard structures that we did are first linear, trigonal, planar, tetrahedral, then trigonal bipyramidal, then octahedral, then pentagonal bipyramidal. Yeah, those are the standard structures. And then you have the deviations for the same. Yes. So we've done cases ranging from AB2 to AB7. All right. So now, people, the homework for this one is actually important and this is something that you should spend time on. Okay, the first thing of course is NCERT once again because we are back to a chapter that is written properly in NCERT. Okay, the second thing that you should do is draw all of these in your notebook. Okay. Okay, draw all of these in your notebook and चलो अगर कर लिया तो बहुत अच्छा है and write examples of all. Okay, write the examples of all. Find out 2 to 3 examples. Okay, 2-3 example खुद से try to find them out for all of these cases because there are only a certain number of standard cases that will come. Okay, वो कर लोगे तो तुम्हारा पूरा chemical bonding का VSEPR will be easy for you. Now let me just check what tutorials you can do and then yeah, pretty much that's it for today's session. कुठे आहे tutorial? पता नहीं कितने बैचेस आ रखे हैं. Janardhanan, the phase test is on 26th. Okay. The phase test is going to be on 26th. Yes, yes, that's final. Aditya, just a little यार, because I was in IIT Bombay for 5 years, तो एक आधी चीज पता है मुझे. I think you can do this. Yes, tutorial 3 is something that you can do. Okay, बहुत सारे अच्छे questions है इसमें. Okay, so tutorial 3 complete करो, and you'll be a master at VSEPR theory. That is all to the theory of this particular case, and I'll also give you this link once again. ठीक है, so people VSEPR कर लिया. Next time we'll do valence bond theory and I'll try to dive into hybridization as well. Okay, next to next class अपन hybridization थोड़ा और समझ के we'll do molecular orbital theory. Okay, class next to that we'll finish up with hydrogen bonding and whatever's remaining with this class. Okay, so 1, 2, 3, maximum 4 classes more for chemical bonding. Okay. Yes, yes, phase test तक सब खत्म कर देंगे chemical bonding का. Okay, so phase test में you will have chemical bonding as well. आदित्य वो भी कब से नहीं आई दोस्त, because all of my cousins are abroad now. इंडिया में जो cousins हैं वो शायद एक भाई है मेरा बस इंडिया में, cousin brother. Anyway, so what did I teach in this session? VSEPR. What are we going to do in the next session? आजा नीचे. Valence bond theory and hybridization. ठीक. So this is what we'll do in the next class. कर लिया अपन ने. अरे यार. What is going on? Okay. ठीक है. So people, technically the class is over. Practice VSEPR properly from the tutorial and your life will be sorted, because VSEPR से बहुत सवाल आते हैं. So please make sure that you do. Okay. Practice the tutorial and yeah, well, that's pretty much it, my dear friends. अरे गिरजा अभी नहीं. मेरे को सांस भी मुंह से लेना पड़ रहा है यार. बीट बॉक्सिंग मत करवाओ आज. So yeah, people, if you want to leave, you can leave right now. We are here just for another 4 to 5 minutes. Samyukta, is that bad? हाँ यार, पता नहीं क्यों. Hate these air conditioners, and I didn't even bring that. क्या होता है वो? Nasal spray आज लाया ही नहीं मैं. For the last 2 days I was using a nasal spray. आज मैं लाया नहीं. I don't want to use it every day though, but. Oh, okay संयुक्ता, कोई बात नहीं यार. ऊपर नीचे चलता है. अच्छा ऐसा है क्या? श्रुति, आई थिंक आई हर्ड अबाउट दिस मूवी. देखी नहीं है बस मुझे. डोंट वरी श्रुति, फिक्शन इज फिक्शन. लेट फिक्शन बी फिक्शन. वाह आदित्य, गुड. कोई ना, खुश कमेंट संयुक्ता, चिल मारो. Everyone has their own relative frame of reference. You should always hold yourself up to higher standards, by the way. I mean, if your goals are so. In college, my goal used to be pass hona. So I was like, pass ho gayi ye. And in IIT preparation, of course, it was like jitna marzi marks aa jaye, it is less. Interesting. चलो अपन मिलते हैं ट्यूसडे को फिर people. Okay, so I'll end up the session right now. I'll go and have something to eat or drink. ठीक है, so चलो मिलते हैं. We'll see each other on Tuesday. Do practice VSEPR. अच्छे से tutorial कर लो and yeah, you now have all of the visualization in mind. People find VSEPR difficult because they don't visualize things. The ratta hai nahi isme. It's all about visualization. Yeah. So chalo people, that's it from my side. Bye bye. See you soon. Good night. And we'll meet each other on Tuesday. We'll continue with the chapter of chemical bonding, VBT and hybridization. Bye bye.